Hello, so this is a summary of lessons 9 through 11 that we had done on the 28th and 29th of October. The first part we looked at was just comparing data, so being able to look at statistics and make a conclusion and support our argument based off the data. So for example, looking at these mean and standard deviations for Phoenix and Orlando, these were looking at high temperatures all across 2021. Coming up with some of these arguments, I was looking for things like maybe Phoenix is generally a hotter city because their mean temperature is higher than Orlando. Orlando is more consistently around 84 degrees because its standard deviation is lower than Phoenix by, say, 6 points. Even including some of these. So in our arguments, we want to include what did we use to compare them, and if we want to further support our argument, we can include those numbers. So saying if I did compare Phoenix to Orlando, saying Phoenix tended to be a warmer place because its mean temperature was 88 degrees Fahrenheit, while Orlando's mean temperature for the year 2021 was 84 degrees Fahrenheit. So we can use this data and those specific numbers to help support our argument. The other thing that we had looked at in this lesson was interquartile range. So sometimes we look at interquartile range as a way to look at the central data. It is another measure of spread similar to standard deviation, but while standard deviation looks at the entire bit, interquartile range, actually there's a slide for that, there we go. So standard deviation here only looks at this entire range, so it includes the outliers. Interquartile range is going to look at just the range of the central part of the data. So kind of similar to how outliers can affect the mean but not necessarily the median. Outliers are not really as incorporated in the interquartile range, while standard deviation includes those outliers. Then we actually found out how to find the interquartile range. That's that abbreviation IQR. You take the right side of the box, the central box number, so at least on that top one they got 27, and subtract it from this number at the bottom of or the left side of the box. So we're basically finding the width of the box in the box plot. So for example, looking down here at Miriam's, I would go to the rightmost side, which is at 25, and then subtract it from the leftmost side, which is 20. So 25 minus 20, I should have an interquartile range of 5. And as we go in there, have it check the work, it should show us that we are correct. So take the right side of the box, subtract it from the left side of the box to find the length or width of that box in the middle. The last thing that we were looking at briefly was interquartile range, outliers. So with outliers, they're generally, again, those numbers that are really far above up or below the central point of the data. Technically, it is within 1.5 of the interquartile range to be considered an outlier. So there's some that may have data points that are fairly similar, but they are only considered an outlier once they are 1.5 width above or below the interquartile range. We're not going to look a whole lot of those specifics. I mostly want you to be able to see outliers and specifically see that they alter the mean here. This person on the left chose the mean, while this person on the right chose the median. If I look at where most of the data is, most of the points that this person got are around that 6 point. So if you have an outlier, it is better to use the median rather than the mean. And the biggest thing with this that I kind of want to keep in mind, so outliers affect the mean. So if you've got an outlier, probably don't choose mean for your central data point. If you do have an outlier, choose the median. If you don't have an outlier, both of them should end up being about the same. That's a basic summary of what I wanted you to be able to get from this lesson.